Okay, guys, welcome back. Today's new stuff, we're going to look at 282. So we're going to look at different functions as transformations of each other. So first thing, we have four different functions. Remember, we can use any letter, not just f. So I have f of x, g of x, h of x, and q of x. I'm going to graph these. And let's see, I want to use different colors. So we'll do f of x in blue. So f of x equals 3x. That's really 3x plus 0. And I have a slope of 3 over 1. So up 3, right 1. I can go down 3, left 1. And that was kind of a straight line. Next, we'll do g of x. So that's plus 1. And let's see, I can't go up 3. So I'll just go down 3, left 1. Next, we'll do h of x. So plus 2. Definitely don't have room to go up, so down 3, left 1. And then lastly, we'll do q of x, 3x minus 1. So down to negative 1, up 3, right 1. And it looks like I have 4 parallel lines here. Okay. So let's find the y-intercept of each. I'll kind of do these in order, or color-coded. So q of x was the last one. That was 0, negative 1. Let's see. Red was h of x. That was 0, 2. Oh my gosh. What did we do? All right. Then we had orange was g of x. That's 0, 1. And then blue, I think was the original. That's at 0, 0. That was f of x. So how would you describe the translation of h of x from f of x? From f of x. So I start at f of x. So f of x in blue to h of x in red. It looks like I'm going up 2 units, right? I'm going up 2. So shift up 2 units. How would you describe, so from h of x to q of x? Q of x was green. So from blue to green, I'm going down 1 unit. It's easiest to pick a point where you know, and then see where that point moves to. So that is shifting down 1 unit. How about from g of x to q of x? So from g of x, which is orange, to q of x, which is green, I'm going from that point there down to there. I think we're going down 2. So shift down 2 units. Okay, so that's if you have equations and you're going to the graph. Over here, we're going from the graph. Well, let's see. Well, this is just kind of a different problem. So same idea though. I have f of x equals 2 to the x plus 1. That's the graph that's shown. I need to find g of x, which is f of x minus 5. So the original graph minus 5. Well, that minus 5 is going to shift down 5. So what I want to do is pick a handful of points that cross over the grid lines where you know like exactly where the coordinates are. And I think I also want to draw an asymptote on here because we know where the asymptote is. And then the 3 points I've just highlighted and the asymptote are all going to get shifted down 5. So let's shift the asymptote first. It looks like it's at positive 1. I'll shift it down to negative 4. And then this point here at 0, 2 is going to go 1, 2, 3, 4, 5. Down here to 0, -3. This one here at 2, 5 goes down to 2, 0. And the point here at 3, 9 we'll go to 3, 4. So I don't know any of the points on this piece over here, but I know it's getting closer to the asymptote. And it would look something like that. So I've shifted f of x down 5 to get g of x. Okay. Rule means equation. So I have f of x, I have g of x. I need to write a rule for g of x in terms of f of x. If the rule is for g of x, that comes first. In terms of f of x, that means f of x will be a term in the equation. And then you need to tell me the transformation over here. So g of x equals is the same as saying is. So g of x is f of x, but shifted. So let's pick a point on f of x. Let's pick that same point on, or that corresponding point on g of x. And I need to go up 1, 2, 3, 4, 5, 6, 7 units. So g of x is the same as f of x, but it would need to be shifted up 7. So that's how I write a rule. And then here's 2 last ones on this page. 9, you have f of x, you have g of x as equations, and you want to write g of x can be written as f of x plus k. What's the value of k? All right, so g of x can be written as, that's another way to say equals, g of x equals f of x plus k. And then I have an expression for g of x. So let's, underneath that, let's substitute in 2x minus 2. That's what g of x is equal to. I have an expression for f of x. So let's substitute that in. So 2x plus 1. And then let's not forget about the plus k. Keep that as is. What's the value of k? Solve for it. Isolate. Get everything else on the other side. So let's subtract 2x. That's gone. Subtract 2x. Ooh, that's gone from the other side. Subtract 1. Subtract 1. And I get -3 is equal to k. Next. Same thing. I have f of x. I have g of x. G of x can be written as, so g of x is equal to f of x plus k. I think it's the same setup. G of x is really 2x, or 2 to the x plus 3. F of x is really 2 to the x minus 1, and then I still have my plus k. That's what I want to solve for, is k. So again, get everything to the other side, away from k. It's kind of weird subtracting exponential terms, but they are the same value, so they cancel out. Add 1, and I get 4 is equal to k. That's it. That's what we're doing. Thanks.